Dr. Taylor is continuing his research in laboratories with students, professors, and researchers from various fields. Computer science, robotics, computer-integrated interventional medicine, radiology, surgery, etc. He has been researching across diversified fields for over 45 years. Dr. Taylor, the founder of the field of surgical robotics, which brought about a revolution in the relationship between robots and medical treatment. He is also widely known as the father of medical robotics. The birth of computer-integrated interventional medicine. What is brought about by the establishment of a three-way partnership among people, information, and technology. 1948, Russell H. Taylor was born. His father was an engineering manager working in the defense and space industries, and his mother had been trained as a mathematician. Both parents greatly encouraged their children to love learning and to incorporate a strong sense of ethics and hard work into everything they did. Young Taylor, who liked to read, became interested in technology and science-related fields through aerospace magazines around the home, and was influenced by his father's job. While he was in high school, he often spent Saturdays at the Franklin Institute Science Museum. He took a computer programming course at the University of Pennsylvania in the summer after he graduated from high school. 1966, enrolled at the Johns Hopkins University. Dr. Taylor entered the university to study engineering. Although he did not realize it before he arrived there, Johns Hopkins combined the advantages of a small undergraduate population with those of a major research university. Since the computer science major had not been introduced yet at Johns Hopkins, he pursued a broad interdisciplinary education, including courses in mathematics, electrical engineering, and operations research. Education within the university was also integrated with its research activities. Encounter with his mentor, Dr. Mandel Belmore. His encounter with Dr. Belmore gave Dr. Taylor a chance to apply computer programming skills that he had learned to important research problems. He learned many different things from Dr. Belmore. For example, how to convert a problem in reality to a problem in the academic world, and how to reconvert a theoretical solution found therein into a solution applicable to a problem in the real world. This encounter with Dr. Belmore was a significant life-changing event, which greatly influenced Dr. Taylor thereafter. 1970, received a Bachelor of Engineering Science degree from Johns Hopkins University. Same year, he entered the Computer Science PhD program at Stanford University. Dr. Taylor joined the Stanford Artificial Intelligence Laboratory. He found the AI lab very interdisciplinary. There were people from various specialized fields such as computer science, mechanical engineering, robotics, etc. This interdisciplinary environment was very unusual for the time and inspired great creativity. He joined a project called Hand-Eye Robot Project, which required knowledge from fields such as robotics, computer vision, manipulation, sensing, programming, etc. He greatly extended a programming language, SAIL, and co-developed AL, a programming language for sophisticated robot programs. 1976, received a PhD in computer science from Stanford University. In his PhD dissertation, he established a methodology for automatically programming robots to combine sensing and manipulation to perform precise mechanical assembly tasks from task descriptions. 1976 through 1995, joined IBM's T.J. Watson Research Center as a research staff member. Dr. Taylor joined IBM Research after he was recruited by Peter M. Will, who was then an IBM Research Manager and leading the robotics department. At IBM, Dr. Taylor led the development of a new programming language, AML, which was optimized for robotic systems, integrated into complex manufacturing and test applications. This led to a 2-year assignment as the product architect of the IBM RS-1 and 7565 robotic systems, after which he returned to IBM Research. While continuing his own research, he became a manager responsible for a variety of robot, computer vision, and integrated systems projects relating to IBM manufacturing processes. He led development of a prototype hip replacement surgery assistant robot, which was later called RoboDoc. This was the world's first medical robot to perform a major surgical procedure. Through this project, he felt confident that robots and computers could greatly contribute to the medical field. His work led him to think more broadly about how robots fit into what he calls computer-integrated interventional medicine, which has become his lifelong research focus. Examples of his work include the development of a prototype of a surgical navigation system for craniofacial surgery, the remote center of motion mechanism for minimally invasive surgery, the laparoscopic assistant robotic system, LARS, and much more. 1995, Dr. Taylor moved to Johns Hopkins University in order to work more closely with surgeons and other physicians. He is now the John C. Malone Professor of Computer Science, with joint appointments in mechanical engineering, radiology, and surgery. Dr. Taylor is also the director of the Engineering Research Center for Computer Integrated Surgical Systems and Technology, and of the Laboratory for Computational Sensing and Robotics at Johns Hopkins University. In recent years, the number of medical robots that are patient-friendly and minimally invasive has started to increase. Application of these medical robots is helping to shorten hospital stays and reducing medical expenses. However, there are still a number of challenges to overcome, Dr. Taylor says. Dr. Taylor has always recognized his main research theme as being computer-integrated interventional medicine. What Dr. Taylor emphasizes the most is providing appropriate treatment through a 3-way partnership involving physicians, technology, and information. For Dr. Taylor, Johns Hopkins University has been the ideal university to conduct his research. Dr. Taylor had the following to say: "The most important aspect of a university is people. The most fascinating factor about moving to and researching at Johns Hopkins University is the environment where professors can conduct research together with young people, including undergraduate students, as well as graduate students, postdoctoral students, and other faculty. Any university must keep in mind that its mission includes both advancement of knowledge and education of the people who will further advance and apply that knowledge in the future." Since receiving the Hamilton Award, which targeted undergraduate engineering students, Dr. Taylor has received numerous awards, most recently the Technical Field Award from the IEEE Biomedical Engineering Society. He has also authored over 400 research papers and publications. He has been also appointed as a Fellow of the IEEE, the ENBI, the Mekai Society, and the School of Engineering of the University of Tokyo. The importance of integration between robots and medical treatment, which Dr. Taylor pioneered and developed, is increasing every year.
My dream really is to be able to see technology applied in a very affordable way, much more broadly, to help us treat each individual patient in a better way. And also, again, to build this partnership between people and information and technology for treating of patients. So that's very much the theme of my work, and what ideally you'd like to see that practiced much more broadly than it is today. I don't know if you always have to have a robot. You could have a robotic device, you could have a sensor, you could have a smart system, so that as we treat each individual patient, we can do it the most ideal way possible. That's my dream.
Utilize technology and innovation for people and challenges across society. With vigorous leadership and achievement, Dr. Taylor can still be found actively engaged in numerous endeavors in the fields of education and research. By upholding the mission of advancement of education and knowledge, Dr. Taylor is continuing his research surrounded by young researchers.